Hey, a little while ago I was browsing the interwebs and I found this cool page with a bunch of really cool GIFs on it, and one of those GIFs that you see behind me here. And I figured it's not too hard to make, so if it interests you, then let's make it together. Let's get started. Alright, so I have a empty shader over here, so let's do some cleanup. Get rid of some of this stuff, and let's just start with a black screen. So I'm going to do vec3 and then make it black. And over here I'm going to normalize my UV coordinates, minus 0.5 times I resolution.xy. This is just to make sure that we account for the aspect ratio and also that the UVs are 0 in the middle of the screen. So that just gives me a black screen. And now I'm going to make a grid. So for a grid, let's say go over here. And I'm going to make a vec2 GV for grid UV, and that's going to be my UV times some larger number. And now my UV would go from, well, if over here it would go from minus 1 to 1, then over here would go from minus 5 to 5. I don't want that. I want it to go like from 0 to 1 each time, so I can put a fract around that. So let's visualize that. So I can just do it like that, and there is a bunch of boxes. And now my boxes, all the UVs inside the boxes all start at 0 in the lower left corner, and they go to 1 in the top right corner. I want the 0 to be in the middle, so for that I can just subtract 0.5. So now my 0 is in the middle. And now let's draw a circle inside of each of these boxes. So for that I'm gonna have to calculate the distance from each pixel to the center of its own box, and that in this case is just the length of the GV coordinate. And then I can use that to cut out a circle with a smooth step function. So I can say, let's say 0.4, 0.3, d. And now let's add that over here, plus equals m. Okay, so now I have a bunch of circles. And now these circles, they're gonna shrink and they're gonna grow. And when they grow, they will overlap. They're gonna have to overlap their neighbors. And so for that, we have to, because right now we divided everything up in boxes, and so we're only evaluating one circle at a time for each box, which is fine if they don't overlap. But if they start overlapping, then we need to evaluate all the circles, all the potential circles that could overlap with a circle. So if we're looking at this circle here, then we have to take into account all the circles in the 9 or in the 3 by 3 neighborhood around that circle. So for that, I'm going to make a double loop. So I'm going to start with y, float y equals minus 1, y smaller than or equals 1, and then y plus plus. And I'm going to do the same thing for x. And over there, and do that, and x, and x, and x. And now I'm going to make an offset inside of here, vec2 offset equals vec2 x comma y. And so this offset is going to let's say we're inside of this cell over here, then that offset is going to be minus 1, which is that cell, and then it's going to be 0 minus 1, which is this cell, and then it's going to be 1 minus 1, and so on and so forth. So it's going to kind of scan through all the neighboring boxes. And let's set this to 0 over here. So I'm going to go 0. So that my m value is going to accumulate all the brightness for all the circles. So then over here, I can do m plus equals smooth step d, and then I'm going to take my d value and I'm going to also put that inside of the loop over there. And then so right now it calculates the distance to the cell that we're in, to the center of the cell that we're in. So if this is the cell that we're in, then that length GV would be the same as length GV plus an offset of 0, 0, right? But if I do this and it's going to go through all the different combinations here, then if this is the cell I'm looking at, then it's going to, the first time it goes through this loop, my offsets are going to be -1, -1, so it's going to evaluate this cell, and then it's going to evaluate that cell, and then that cell, and so it's going to go through all 9 cells. So if I do that, like right now, I wouldn't expect anything to change. So let me see. So no, nothing changes because it takes the other cells into account, but those the circles are not overlapping, right? So you will not notice. So let me just make a float R for radius over here, and let me just hard code it for now, and then instead of the numbers here, I'm just going to do radius and radius times some smaller number. So that shouldn't change anything. Well, like a little bit because it's a bit larger. So now you don't notice it, but let's see what happens if we make them larger. So 0.5 would be all the way to the edge of the box. But now if we make them even larger, we should start seeing some overlap. And we do, right? You can kind of make out some overlap over here. So that tells me that this is correct. So now what I'm going to do is I am going to vary the sizes of those circles. So for that I have to animate this radius property over here. So what I could do is, let's say I could use a mix for this, and then I could say, well, my smallest radius that I want is, let's say 0.3, and my largest radius, let's just stay in the box for now, 0.5, and then I'm going to have to put in a number here, right, to kind of mix between those two. So if I put 0 here, then my boxes are going to be 0.3, and if I put 1 here, my boxes are going to be 0.5. So I'm going to animate this value over here. So I'm going to use the sign of I time. So this I time over here is just this value over here. So I time is a value. If ever you need to animate something, you need to use I time because it needs to be a function of time. And I'm going to stick that into a sign, and a sign goes from -1 to 1, and I don't want that. I want something that goes from 0 to 1, so I'm going to have to convert that. So what I'm going to do is I'm going to multiply it by 0.5, so now it goes from -0.5 to +0.5, and now I'm going to shift it up by 0.5, so I'm going to do +0.5. So now I have a value that goes between 0 and 1, and you see that it animates here. Okay, so that's already pretty cool. Let me take this time value out here and call it just t, and then over here I will specify time, or specify t to be I time, because then later if I wanted to make it faster, then I could just do that here instead of inside of the loop. So now it goes a little bit faster. All right, so I want this to animate based on time, like the size of these circles, but not just on time, but also on the distance from the center of the screen, right? So like right now, this value over here is only a function of time, but I'm going to make it a function of time and the distance to the center of the screen. So to calculate the distance to the center of the screen, I need this UV value over here instead of GV, right? So GV would give me the center of the box, but I want the center of the screen. So I could add some offset here plus the length of UV. So that's the length to the center of the screen. Well, let's just actually see what that does. Well, it's hard to see, but if I multiply this by some larger value, then you will see what it does. So that already kind of does what we want, perhaps. But let's see, there is an issue with this, because let's see if we multiply this by some very large number. So now you see that it starts screwing up all my circles. This is tea, by the way, not beer. It starts screwing up my circles because for every pixel, that the distance is different. for every pixel inside of the box. And what we want is we want inside of the box for every pixel we want a uniform scaling. So we can't do this. And even so, this is not a good idea to do it like this because this term here does not change, but we're evaluating that 9 times because it's inside of both of these loops, right? So if ever you wanted to do this, then like you always want to see what's inside of the loop, and if there's anything inside of the loop that is not dependent on any variable that changes in the loop, then you want to take it out if you can, because otherwise you're just doing a bunch of operations for nothing. So you would take this out. So let me take that out over here, and let me call this dist, let's say, and then over here I'm going to calculate my dist. So I'm going to do so I could do float dist equals this. All right, so that doesn't change anything, but it is a lot more performant. But we don't want the distance to be different for each pixel. So what we have to do is, what I'll do instead of taking the distance from the pixel to the center, I'm going to take the distance from the box to the center, so that for each pixel inside of a box it is the same. And to do that, I'm going to go over here. I'm going to go vec2 id. So I'm going to make an ID for the box so that every box has a different number. And I'm going to do that like this, floor, and then UV times 5. And because I'm doing this twice here, I should probably put that in its own variable. But for now, let's just do it like this. So now I have an ID value. So instead of my UV, let's use the ID value. And now you can see that the scaling inside of the box is uniform, so we don't get that weird wobbly circle anymore, which is what we want. Okay, so now we have to, well, now we still have to put this inside of the loop, because now it's going to get a little bit different. Because now each time I get through this loop, I have to get the distance to not just to the box we're in, but like the distance to the center of, let's say, the box above to draw the circle above. So what I have to do here is I would have to also add the offset here to get the right size for that particular box. Right now that shouldn't change anything because my circles aren't that big. But if I make my circles bigger, so let me just make them just a little bit bigger so that they overlap just a little bit. And then we can see they overlap, but there's some screw up going on. If I just stop that for a second, and you can see, let's say this one is bigger than the box and it gets cut off, but over on the other side of the neighboring box it has that circle. And so that is because, like over here, this was actually wrong. Here I have to actually subtract the offset, and now you can see that we have the circles correct. Awesome. So now we have overlapping circles. And also let's see how big can these overlaps get. So if this is the center of my box, and so the boxes are 1 by 1 in size. So if I'm in the center of this box, then my circle can, the largest radius it can have inside of the box is 0.5. And it can now overlap with its neighbor, but it cannot overlap any farther than one neighbor, right? So we have to scale it, or the largest it could get is, if this is 0.5, then this would be 1 over here, and then this would be 1.5. So the largest our circle can get is 1.5. So let's just add that over here. And then it's probably going to get really white. Yes. So just in order to visualize that, I would have to multiply this by some smaller number to still be able to kind of see what's going on here. I could just also turn off the boxes itself so we could see that. So that could already be cool. I don't know, you could probably do something with that. But I didn't want to do it like that because in the effect, it looks like they have it so that if for every pixel, if there is an odd amount of circles in that pixel, then it should show white, and if there is an even amount, it should show black. So in this case, this pixel under the cursor right here should be white because there's only one circle. But then over here it should be black because there are two circles over here. And then over here it should be white again because there's one circle. And when there's three circles overlapping, let's say, I don't know, over here, that should also be white. So odd means that you show it, even means you don't show it. And so how can we do that? Well, we can, so over here, this M value is basically just counting, for every pixel, counting how many circles are overlapping it, right? So if I do this, it's very bright because there might be three circles overlapping or whatever, and so anything past one is already white. But what I can do down here in order to make it so that only the odd number of circles show is I can use a modulo operator. So if I do this modulo with 2, then that will wrap the numbers so that only the odd numbers will still show. So that is kind of already the effect. So let's zoom out a little bit. So what I can do is so over here I said I didn't really like this over here, so let me just go over here and do UV times equals 10, and then over here I could just use the UV by itself. Okay, so now we already have something that looks pretty trippy. So let's try to tweak this a little bit. So let's I think this value here is too large. Let me just make it smaller. Okay, so that already looks better. So now let me make it that it zooms out a little bit on the entire screen. That's still a bit too much here. Let me just make it even smaller. Okay, so now we're getting somewhere. Now, I don't like that this wave is coming in. I'd rather have it that the wave goes out instead of coming in. Well, that's easy enough. I could just like turn this T around over here, and then I usually don't like it when it says minus and then plus something. So like what I rather have is just turn them around so that you can just get rid of this plus here. All right, so now we have something that looks already pretty cool. So it's going a bit fast, so let me just make it slower. Okay. All right. So let's see, what else can we do? Yeah, so this grid right now, it is straight, right? So like these circles are, they're axis aligned. I think it will look cooler if they're 45 degrees rotated. So for that, I can just go over here, UV, and then multiply it by some rotation matrix that I'm going to make. So I'm going to mat 2. And I talked about rotation matrices before, but just really quickly again, what we do here is we take the cosine of some angle, and then the negative sign, and then the sine, and the cosine. And I'm going to make these as variables. So first variable, I'm going to do the angle. So and for the angle, I'm going to take 45 degrees. I think that's pi divided by 4. I'm not entirely sure. So let me just try this. I hope I'm correct on this. And then I'm going to make the sine of the angle over here, and I'm going to make the cosine of the angle. And let's see what that does. Okay, so that rotated it, well, not entirely by 45 degrees. Interesting. Let me just, does that not change anything? Interesting. Well, anyways, it's somewhere around here. So you can figure out exactly what the angle should be. So basically, that's just 45 degrees in radians. That's what we want. Okay, so let's press play here. So that looks pretty cool. So right now it only shows the the odd number of whenever there's an odd number of circles. With this modulo operator, you could play. You could also make it that it only wraps every 3, so you get like a different type of pattern. But I think the 2 is better. Now there is one thing here that will become more obvious if you make the circles more soft. Okay, so right now the circles are fairly hard edged, but if I make them softer, then you could see that we get this ugly sharp artifacting here, which is not generally what you would want. And that is that is caused by this modulo. So another way of doing this is we can use an exclusive OR operator, and that is an operator that it's a function that here, let me just write it out. A function that takes 2 inputs, A and B, and it will return 0 when both inputs are the same, and it will return 1 when they're different. So for that, I can just do this: A times 1 minus B plus B times 1 minus A. And let's just really quickly run through this. So, and I'm assuming here that A and B are between 0 and 1. They're kind of 0 or 1. So let's say that if they're both 0, then what we get is we get 0 times something, which is 0, plus 0 times something else, which is also 0. So if they're both 0, then the output will be 0. If they're both 1, and let's see what happens. If they're both 1, then we get 1 times 0. So this is 0, and here we get 1 times 0. So if they're both 1, then it's also 0. If let's say if one of them is 0 and the other one's 1, so let's say A is 0, then we get 0 times something, which is 0, plus if B is 1, like 1 times 1 minus 0, which is 1. So if both of them are the same, then this will return 0. If both of them are different, this will return 1. And so what we can do is we can use that XOR operator to each time we get through it, we just do this. And so then, like the first time we go through it, let's say we have our first circle. So the first time we go through is this M is 0 and this circle is 1, so this will return 1. And the second time it goes through it, like my M is already 1, and if I have another circle, then I have 1 and 1 goes into it, so then it will return 0. So this will also oscillate between on and off. And let's just see what this does. And you can see that this makes a much nicer looking blend. So that's a little tidbit that you might use for other effects or what. So let me just make it sharper again. So times 0.9, and yeah, that's pretty much it. So let me just put it over here. So I hope you like this this little effect. Now you could play with this. So like right now, every circle gets scaled based on the distance from the center. You don't have to do that. You could have multiple centers that are like maybe moving around, or you could I don't know, make multiple layers of this that are like blended in a certain way. If you make something cool, be sure to post it in the comments below. And either way, I will see you next time.